1.4 Quadratic Functions. In this section, we're going to be looking at two different sides of working out a problem. First would be the equation side, which is going to be the first couple slides. And from there, we're going to lead into some working with word problems. Now, on the right-hand side of the screen, you can see that our Inspire is going to be there. I'm going to be working with you guys to have you also use your calculator with these different problems, how to use them, and how to do different functions from this point. So we're starting off with writing an equation given the information. So this will generally occur based off of what is exactly there. So for example, when we find the vertex and a coordinate, our coordinate is xy, we are going to have that xy within our equation. Now, our general equation is going to be y is equal to a times x minus h squared plus k. All we are going to do with that xy is plug into that equation. And we're going to do the same thing with the vertex. Remember, our vertex is the h and k. We're going to also plug that information in. What ends up happening is we will end up with the remaining letter of a being there. Now this is important because we're going to solve for a within that problem. So let's take a look at this problem here. So we're going to begin with taking a look at this problem. So here we have our vertex being -6, -4, and our point being -2, -12. This is the same thing that we were discussing before in the previous slide. We're going to plug in our x and y and our h and k into the problem itself in order to find a. So we go ahead, we plug in all of our numbers, as we can see down here. And once we do, we get a value of a being 1. Now, the answer is not 1. That is just the value of a. In order for us to finish off the problem, we need to insert two things: the value of a and the vertex. So notice we're not plugging in x and y. We are only plugging in our vertex, which is h and k, and the a that we had previously found before. So let's take a look at the second part. Once we find out that a is equal to 1, we go ahead, plug it in for our a right here. And at that point, we go ahead and insert our vertex. H is -6, k is -4. We go ahead and plug it into our standard equation, which is y is equal to a times x minus h squared plus k. Keep in mind, even though we have a -6 and we are subtracting, that will turn that x minus a -6 into a +6. This down here would be our final answer of y is equal to x plus 6 squared minus 4. Now, this exact same thing can be done with a graph instead. We know our generic equation. We know our y is equal to a times x minus h squared plus k. Now, using this, we need to go ahead and use the points that we know to our advantage. We go ahead and find our vertex. Our vertex is right here at -2, -4. And we are going to need to find another point. Now, when it comes to finding a point, I highly suggest that you find one that crosses one of the different lines perfectly and meets up at that intersection. So for example, you could use 0, 8, or you could use -4, 8. You could use -3, -1, or -1, -1. All of these 4 points even though they are four different sets of numbers, you will still end up with the exact same answer. The most important thing is that you are using a, a point that is easiest for you to use. Keep in mind, because of the fact that we do not have numbers outside of our whole numbers that we're using, it becomes much more difficult to be able to place the proper point. So you want to use your whole numbers because we know that those work 100%. We go ahead, plug in our points. So in this case, h and k, -2, -4. And we're going to use our x and y, which is going to be 0 and 8. Using those values, we go ahead, we plug them in. 8 is equal to a times 0 minus a -2, so 0 plus 2 squared. So 2 squared is 4. 4 times a is 4a, minus 4. We add 4 to both sides. 12 is equal to 4a. A is equal to 3. We then go ahead and plug in that 3 and our vertex into the equation itself. Slide 5. Once again, same exact process is taken. Here, we're going to go ahead and grab our vertex, -2, +4, and we're going to plug that in. Easiest point for us to use here would be 0, 0. We go ahead, plug in our 0, 0, plug in our -2, 4. We end up with 0 is equal to a times 0 plus 2 squared. So 2 squared is 4, 4 times a, plus 4. We subtract 4 from both sides, divide by 4, and at that point we end up with a equaling -1. Once you go ahead and solve for a, we go ahead and plug it back in. We plug in the value of a and our vertex. Now this is the location where we start focusing more on word problems, how to use our calculator. Now keep in mind, on the right hand side, this is what it would look like as far as turning on your calculator. If you're not exactly sure on, or you end up on a different screen other than this, highly suggest you go ahead, you click the on button. Notice the home is there as well, which means it's going to take you back to this main screen that you have. So word problems. So instead of giving you an equation directly to solve, the problem is presented in the form of a story. Based on the story, you have to form the equation and be able to solve it. So when solving problems that lead to a quadratic equation, we may get a solution that does not satisfy the physical constraints of a problem. For example, if we were to measure out a table, is it possible for you to end up with a negative number? No, you're either going to end up with 0 or a positive number when you're measuring something out. It is impossible for you to measure an item and end up with a negative number. Let's go ahead and take a look at slide 9. In slide 9, it says identify the known information, identify the unknown information. Maybe you might need to use your variables as far as x, y, or z, or different variables in order to represent those items. You go ahead, you form your quadratic equation using the given information that you have been presented within the problem. You solve that equation, and then you check to make sure that that equation and your solutions make sense as far as what you've come up with. Let's take a look at our first question. So, in our first question, let me just slide this over. Now, in our first problem, it says a softball is thrown upward with an initial velocity of 32 feet per second from 5 feet above the ground. The ball's height is in feet above the ground is modeled by h of t. Notice whenever t is generally used, it will refer to time, is equal to negative 16 t squared plus VOT plus HO, where t is time in seconds after the ball has been released. Now, here it's important to be able to kind of understand what generally is used within these equations. For example, V. When we're talking about VO, we're generally talking about the initial velocity of the ball. And when we say HO, we're talking about the initial height. So, what do we know? We know that h of t is equal to negative 16t squared plus VOT plus HO. What is our initial velocity? Well, our initial velocity is 32 feet per second. This would go ahead and replace our VO. Once that replaces the VO, and we talk about our initial height, which is 5 feet, we actually come up with this secondary equation that is right here. Now, we'll start off with problem A. In problem A, it's asking for the maximum height of the ball. So, generally what we would want to do if we have our calculator in front of us, we are going to want to use the scratch pad. Now, you have one of two different options. You can go ahead and click either A or B, whether you want to calculate or whether you want to graph. But you also have this button right here that looks like a little calculator. That will also take you down to the scratch pad. Now, if you go ahead and click on scratch pad the first time, it will take you to the calculate portion. If you click on it again, it will shift over to the graphing part. Now, there are many times where you might see that the actual place for you to plug in your equation is not shown. So what you want to do is you want to click tab, and it will go ahead and show you that inserted tab. Now, how do we plug in our equation? We're going to want to plug in the entire equation, but remember, we do not want to plug in HT. The reason for that is because this would be set to 0. So we're going to go ahead and plug in our equation as negative 16. Now, as we start getting to t squared, I will highly suggest to you that you go ahead and use x rather than t when plugging in for your graphs. You will also need to be able to separate these two terms away from each other. So the negative 16 is separate from the t squared. So we do that by a multiplication sign. Once we hit that multiplication sign, it tells the calculator itself that, hey, negative 16 is different than t squared. We are going to have it in the same term, which is why we're multiplying against each other, but it has to be separate. So x squared plus 32 times our x variable plus 5. Once you've gotten to that point, you're going to go ahead and click enter. When you do, you can already see that the graph has been made for you. Now, there are multiple things that you have to keep in mind with your graphs. you will need to know your calculator. You will need to know how to move around your calculator within the menus in order to get exactly what you are looking for. So for example, here, if we're looking for the maximum, this looks very similar to a parabola. So we know that what we're looking for is at the very, very top, which is hidden outside of the view of the screen. Now, there are one of a couple different things. You can kind of see that there is a hand in the middle of this graph. If you were to click and hold, now notice I'm doing it in a very blank area where there is nothing else for me to be able to grab. If you place your hand over or the cursor over an item, you can go ahead, grab it, and move it and place it exactly where you would like for it to be. Now, on your calculator, you would have to hold down that button for several seconds in order. Once you see the hand close, then you know that you can grab it. Once you click on it again, it will release it. Now, there is an easy way of finding your maximum. So when we go ahead and find the maximum, we're going to go ahead and hit menu. So notice menu is down here on the right hand side. And we're going to go down to Analyze Graph, number 6. Now, as you start looking through these menus, I want you to understand, you can go ahead, you can hover over each one of these different items and it will show you exactly what you need. If you want to click on it, you can either click on it using this center button, or what I would suggest, just click the number 6. So when you hit 6 on your keypad, notice it opens up the menu for the analyzing graph. You go ahead, you find what you're looking for, which in this case is going to be maximum. Once again, if you hit 3, let's run through that one more time. So we're going to go menu, analyze graph, 6, maximum 3. Now, once we do that, what will happen is that it's going to need for you to basically select the area that we're referencing. So what we're going to do is we're going to look for the lower bound, meaning the smallest side that you would want. In this case, anywhere to your left-hand side would be perfectly fine. Now, if you notice, as we start scrolling to the right-hand side, what do you notice about that maximum yellow indicator? It's moving up, correct? Now, the reason why it's doing that is because as we move further right, it is automatically analyzing the area that you have selected, which you can see is this gray area in the middle between the two lines. And based off what you have selected, it is telling you what that maximum is. Now, in this case, we selected a random point on the graph. And what we're going to do is just run that problem one more time. Quickly type it in. Negative 16 times x squared plus 32t, or 32 times x plus 5. Once we've done that, remember, we're going to go ahead and look for the maximum. So we're going to go menu, 6, analyze graph, 3, maximum. We're going to find our lowest and our highest location. Now keep in mind, as we get to that vertex, does it matter how far we go? It doesn't. The reason for that is because notice it's already indicated where that maximum point of the parabola is. We go ahead, select the entire area, and we have our point at 121. What this means is that after a certain period of time, it will reach its maximum height. So the x, which is our 1, is the amount of time that has passed. So after 1 second, the ball will be at its maximum height of 21 feet. Our answer here would be 21 feet. Let's take a look at B. At what time does the ball reach its maximum height? This is what we were also talking about before. In this case, we can go ahead and take a look at the vertex and say, well, in order for it to reach its maximum height at 21 feet, it would have to be after 1 second. Let's take a look at question C. At what time is the ball at 16 feet high in the air? Now, using the equation that we have, we know the height that we are looking for, which would be our h of t, which would equal 16. Now, as we start working within this problem, there's a little bit of a change that has to happen. We can't insert this equation the way that it is. We need to make sure that it is set to 0. So when we do, we're going to go ahead and we'll get rid of that equation. And we're going to move over this 16 over to the right-hand side. So in order for us to do that, we're going to subtract 16 from both sides. When we do, we're going to end up with negative 16 times x squared plus 32 times x minus 11. When we do, we get 1 and 5. But this is not the exact number that we are looking for. So in order for us to be able to do this, even though the scratch pad will give us an idea of an answer, our best place for us to work with is going to be within the calculator portion, or our scratch pad on the calculator side. So we're going to hit our scratch pad again. And what we're going to do is we're going to go to menu. We're going to go to algebra, which is 3. Polynomial tools, 3. And we're going to find the roots of a polynomial, 1. Now, we're going to have to put in the degree. The degree is the highest exponent of this problem. In this case, it's going to be 2. And we're looking for real roots. We hit OK. And notice, it's showing us that polynomial. Now, it is asking for a to the second power. Now, what they're doing is that they're asking for the coefficients. So in this problem, this would be negative 16. Our second would be positive 32. And our last would be a negative 11. We hit OK. And we verify that everything looks according to how we were planning, which is our equation here, comma x. And we have polyroots in the front. We go ahead and hit enter. When that happens, this gives you the exact value of what we were looking at, which is at 0.44 and at 1.55. Now, These would be our two answers that we would be looking for. I also want for you to use your reasoning to kind of understand what we are working on. We already know that this equation is a parabola. So when we are being asked at what time is the ball 16 feet in the air, keep in mind what goes up must come down. That means that at two separate points, we're going to see that it's going to hit 16 feet in the air. So we will have two answers for this problem. Keep in mind, these would be our two answers, 1.56 seconds and 0.44 seconds. So in case you need the step-by-step for A and B, and the step-by-step for question C. Let's go ahead and take a look at the next problem. Question 11. This one is very similar to what we had just worked on. So, each year a school's booster club holds a dance to raise funds. In the past, the profit the club made after paying the band and other costs has been modeled by the function P of t is equal to negative 16t squared plus 800t minus 4,000, where t represents the ticket price in dollars. What ticket price gives the maximum profit? Now notice, whenever we are looking at some form of maximum, oftentimes we would be able to graph the equation itself. So we're going to go ahead and do the same thing we did before. We're going to go over to our scratch pad towards the graphing side. What we're going to do is graph out our line itself. So negative 16 times x plus 800 times t, or in this case x, minus 4,000. We hit enter. That's what it was. Error over here should be squared. Now, as we can see, we see one line going straight up. And even though we know that this is a parabola because of it being squared, we're not seeing the entire graph. So how are we able to see the entire graph? This is where we're going to have to go ahead and be able to understand that we can use our calculator to zoom in, zoom out, depending on what we need. So let's go ahead and take a look at our options. In this case, we're going to go ahead and change the view that we have. So we're going to go to menu. Now, the best option in this case would be our window or zoom. So we're going to hit 4. And we have multiple different settings. Zoom in, zoom out, quadrant 1, which would give us only quadrant 1, data, and fit. Generally, what you want to do is based off of what's being viewed and what you need, you go ahead and analyze these options and select whichever would be best for you. In this case, I would select fit. When you go ahead and select for it to fit, keep in mind we are seeing a much broader view of what is going on. Now, if this does not satisfy your needs, you can always go back, hit menu, 4, and let's say we go to zoom out. Keep in mind, you see how it says center, meaning it's going to zoom out from wherever you put this cursor and that be the center. So once you click, keep in mind, it will continue to zoom out until you are satisfied with each additional click. You are able to get out of this ability once you hit escape. Notice escape is over here on the top left of your buttons. Once you hit escape, notice you are no longer able to zoom out. What we are looking for though is the maximum. So we go ahead, menu. Once you go to menu, you're going to go to Analyze Graph, just as we did before, and maximum, 3. We find our lowest and our highest that we would want to look into. Now keep in mind, what ticket price gives the maximum profit? We know that the ticket price itself is on our X, and the Y is the amount of profit that we are searching for. So in this case, $25 a ticket would give the maximum profit. We can then go ahead and say, what is that maximum profit? Well, 6. Now, keep in mind, whenever you see E, that truly just means times 10. So 6 times 10 to the third power. Whenever we have 6 times 10 to the third power, that's going to leave us with 6,000. We go ahead, scroll down. What ticket price would generate a profit of 5,424? Now keep in mind, before, when we had this equation, we had P of T. Now this is what we're plugging in. 5,424 in for PT. Keep in mind, when we are plugging in this equation into our calculator, this needs to be set equal to 0. So we're going to move over that 5,424 over to the right-hand side. When we do, we end up with a negative 9,424. So we're going to go ahead and we're going to insert this equation into our calculator portion. And we're going to run through the same process we did before. We're going to go ahead and we're going to go to menu, algebra, which is 3, polyroots, which is 3, find the roots. In this equation, our highest exponent is 2. We are looking for real roots. You insert your coefficients, negative 16, 800, and negative 9,424. We hit OK. Make sure everything is lined up exactly how our equation looks, and hit enter. In this case, in order for us to generate 5,424, we have 2 ticket prices here, 19 and 31. That right there would be our 2 answers. Let's go ahead to slide 12. In this problem, the function s of t is equal to vt plus h minus 0.5 at squared represents the height of an object, s, from the ground after time t, when the object is thrown with an initial velocity of v. At an initial height of h, and where a is the acceleration due to gravity, 32 feet per second squared, a baseball player hits a baseball 4 feet above the ground with an initial velocity of 80 feet per second. Let's mainly focus on setting up the problem itself. In this case, let's talk about the setup as a whole. Our VT is our 80 feet per second, plus the height. Remember, baseball player hit it 4 feet in the air, minus 0.5 AT squared. Keep in mind, that would be the initial height and gravity of that equation, which would be 32 feet per second squared. So 32 feet per second squared. In this problem itself, we're mainly just looking for you to set it up, the problem itself. You do not have to solve it. Let's take a look at slide 13. Slide 13. The length and width of a rectangle are 3x plus 1 and 2x minus 1, respectively. If the area of the rectangle is 144 centimeters squared, find x. Now, in this problem, we would go ahead and set up our equation as a whole. 3x plus 1 times 2x minus 1 is equal to 144. Now keep in mind that when we are working on this problem, it sometimes helps us to go ahead and graph what we are kind of working with. So in that case, we can go ahead and graph out our box. We know that one side is 3x plus 1. We have another side that is 2x minus 1. Our area is equal to 144 centimeters squared. Now, as we are working this problem, in order to get the actual area itself, we need to go ahead and multiply our two sides against each other. Remember, area is equal to length times width. So from this point, we go ahead and FOIL out our 3x plus 1 and our 2x minus 1. We go ahead, FOIL that out. We end up with 6x squared minus 3x plus 2x minus 1. We combine our like terms in the middle to give us a negative x. We're also going to bring over the 144 over to the left-hand side. And the main reason for that is because, remember, we want it set equal to 0 so that we can go ahead and plug it into our calculator. We go ahead and plug it in. We go Menu, Algebra, Polytools, Find Roots. We are dealing with the second power and we are looking at real. We go ahead and plug in our coefficients. 6, negative 1, negative 145. Hit OK. Make sure that our equations match up. And hit Enter. Now, in this case, we are coming up with a negative 29 over 6 and 5 as two possible answers within this problem. We have to remember one thing. When we are measuring, when we are looking at a word problem, even though we end up with negative 29 over 6, and we have 5 as another answer, we have to keep in mind it is not possible for us to end up with a negative 29 over 6 as an answer. Keep in mind, we are looking at the length of something. It is not possible for it to be a negative. In this case, our answer is going to be 5 centimeters. Let's take a look at slide 14. So the sum of the squares of two consecutive positive even numbers is 580. Find the numbers. So what ends up happening here is we first have to understand that when we're working with consecutive numbers will generally refer to x and x plus 1. That would be referring to our consecutive numbers. But when we are talking about consecutive even or odd, keep in mind, if we start off at x, which is, let's say, 0, how do we get to our next even number? We would have to add 2. And that would work for starting from 0 to 2. If we start at 6, it would be 8. This would work no matter what, which means this would be x plus 2. Now, that would work also for odd, but they have to be consecutive. If not, you have to find the distance between whatever you're starting at, which would be x, and that next number. So maybe it's every other even. At that point, because the distance would be 4, it would be x plus 4. Now, with this problem, the sum of the squares of two consecutive positive even numbers is 580. First thing, the fact that we're talking about the sum means we are looking at an addition problem. And we're also looking at the square of those numbers, which means whatever we're going to do, it is going to be to the second power. So if we are looking at x, it would be x to the second power. Since we are looking at the other consecutive even number, x plus 2, that would also be to the second power. Our answer is 580. Our is equal to 580. We go ahead and set up our equation. From there, we go ahead and we multiply everything out. First, we start by squaring x plus 2. That would leave us with x squared plus 4x plus 4. We add x squared to our x squared, which is 2x squared. Once we've gotten to that point and we move over the 580, we're left with 2x squared plus 4x minus 576 is equal to 0. Now in this case, because everything on that left-hand side is divisible by 2, we go ahead and divide by 2 in order to make our equations a little bit easier. We are then working with x squared plus 2x minus 288 is equal to 0. Something to keep in mind is that anytime that we divide 0 by a number, it is still going to be 0. It's at that point that we go ahead and find our roots, right? Menu, 3, 3, 1. It is squared and we are finding real. Insert our coefficients, 1, 2, and negative 288. Hit enter. And we end up with 16 and negative 18. Because of the fact that we cannot have a negative number, our final answer here would be 16. In slide 15, we are taking a look at this problem, which will go over a system of equations. So first thing is understanding the problem that we're working with. In this case, we have both perimeter and area within the sample problem. And it's understanding how to create each one of the equations that we need. So the perimeter of a rectangle is 44 centimeters. Understanding that the perimeter is 2 times the length plus 2 times the width is going to give you that 44 centimeter. The next would be the area, which is length times width is equal to 117. That would give you these two equations that you see here. In this case, we would be able to work on this question using our calculator by going to the menu button, going down to algebra, which is 3. We go ahead and select 2, solving systems of linear equations. And we have the ability to select how many equations that we would like. In this case, since we're only working with 2, we're going to go ahead and select 2. We will be using x and y to describe our variables. So even though we did use L and W in order to describe the length and the width, we're going to use x and y within our calculator. You would then insert these two equations into our spaces. So x times y is equal to 117 and 2x plus 2y is equal to 44. You would then go ahead, hit enter, and at that point you would be able to solve your problem. Let's go ahead and take a look at slide 16. So in slide 16, we are going ahead and taking a look at the area. Now this problem is slightly different from a general problem because it's not just simply asking for what is the area. It is comparing 2 different rectangles and their measurements. So it first starts with the length of a rectangle is 4 feet greater than its width. If each dimension is increased by 3, the new area would be 33 square feet larger. Find the dimensions of the original rectangle. So in this case, our original rectangle is our width multiplied by width plus 4. The new rectangle would be adding 3 to both of its sides. That means that we would then have w plus 3 and w plus 7. W plus 7 is coming from the original w plus 4 plus an additional 3 on top. Our area for the first would be width times width plus 4. Now in the case for our new rectangle, we have the area is equal to the old area plus 33. So we go ahead and work our problem and set it up. So to find the dimensions of the original rectangle, we first have to set our old area equal to our new area. So we go ahead, set w squared plus 4w, which is our w times w plus 4, and we go ahead and multiply that against our equation. Now, we go ahead, we are in the process of comparing the two against each other. So the first thing that we need to do is find what our old would be, in this case w squared plus 4w, and we add the 33. We have the additional 33 from the new area will be 33 square feet larger. We do that and we set it equal to w plus 7 times w plus 3. We go ahead, and when we do, we end up with our two polynomials. Remember, in order for us to be able to solve our equation, we need to go ahead and isolate our variable. So we're going to bring over the w squared. So we're subtracting w squared from both sides. We end up with 6w plus 21. And that is after we have subtracted 4w from both sides. Once we've subtracted that 4w, we end up with the 6w plus 21. We're going to subtract 21 from both sides and end up with 6w is equal to 12. And we're going to divide by 6 on both sides, which gives us w is equal to 2. Here the original width is 2, and once we go ahead and plug in w into our length, we end up with our length being 6. Now keep in mind, every time that we have some form of word problem, double check your unit to be sure that it is accurate. So in this case, it would be 2 feet by 6 feet. Let's go ahead and take a look at 17. In slide 17, here we're looking at the area once again. So an 8-inch by 12-inch picture has a frame of uniform width around it. The area of the frame is equal to that area of the picture. What is the width of the frame? First thing is understanding that we have an 8 by 12-inch picture. In that case, the area would be 96 inches squared. Now just keep in mind that our frame itself is going to be the same as our picture. So we have to remember that at the very minimum, we would have an additional inch for the frame on both the width and the length. This would be the exact reason why we have 8 plus 2x. Notice it would be an inch on this side and an inch on this side. That's why we have 2 times that size. On the opposite side for the length, we have 12 plus 2x. In this case, the width and the width. We go ahead and multiply our two parentheses against each other, and we FOIL. Now keep in mind, we have to subtract the 96 to figure out exactly what the size of the frame would be. We already know that the picture itself is 96, but to find the frame, it would be whatever we multiply and FOIL out minus the 96 to get a final answer. We go ahead, FOIL out our left side, And we end up with 96 plus 16x plus 24x plus 4x squared is equal to 192. Keep in mind the 192 is coming from adding 96 to both sides. Once we do, and we have our final polynomial solved on the left-hand side, we want to get it equal to 0. The fact that we are able to set it equal to 0 would mean that we would be able to find the roots of that problem. And in this problem, 4, 40, and negative 96, they're all divisible by negative 4. So we're going to divide by, sorry, not by negative 4, by positive 4. That's going to give us the ability to simplify our problem a little bit further. We can get our answers by doing the roots side of it, or by going ahead and factoring. Doing the roots within our calculator would mean going to the menu, Algebra, Polytools, and finding the roots of a polynomial. Keep in mind, this is to the second power. We are looking for real. This would be 1, 10, and negative 24. We hit OK. And verify that our problem is correct. In this case, we had the mouse in the wrong location and not in the proper route, so this would actually give us an incorrect answer. We'll quickly retype this out. So menu, Algebra, Polytools, finding the roots. Okay. 1, 10, and negative 22. Ooh, negative 24. We hit OK. Enter. And notice our answers would be negative 12 and 2. In this case, our answer would be 2, because remember, if we are looking for the width of a frame, you cannot have a negative number. So be very careful with the answers that you select. In this case, 2 inches would be the width of the frame. Let's take a look at slide 18. In this case, if a projectile is shot vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height, s, in feet above the ground, t, seconds after projection is given by this following equation. After how many seconds will it be 50 feet above the ground? Now, keep in mind, its height, s, in feet, so we have our variable s representing the number of feet above the ground. We set it equal to 50 as far as our equation, and we are going to bring that 50 over to the right-hand side. This will give us the ability to use our finding roots within our calculator. We go ahead, menu, 3, 3, 1. We hit OK. Now here we do have the ability to simplify it out, but I'm going to show you if we do just insert our numbers of 16, 100, and negative 50, it would still be able to solve our problem. In this case, we have negative 6.7 and 0.46. This would mean that at 0.46 seconds, it would be at exactly 50 feet. Let's take a look at slide 19. Now, this problem was very similar to the problem that we were looking at before on slide 17 with the frame. In this case, a rectangular swimming pool measures 25 meters by 6 meters, and it is surrounded by a uniform path or a uniform width. If the area of the path is 102 meters squared, find the width of the path. First, it's understanding the size of the pool and adding 2x to each one of those measurements. That would leave us with our equation here. We're going to go ahead and set it equal to 0, so we're going to move over the 252. We go ahead, plug it into our calculator. 3, 3, 1. 4, 62, and negative 102. Go ahead, hit enter, and we come up with negative 17 and 3 over 2. Keep in mind, we cannot have a negative measurement for this, which means 3 over 2 would be our measurement, or 1.5 meters. Let's go ahead and take a look at slide 20. So in slide 20, a ladder is resting up against a wall. The top of the ladder touches the wall at a height of 15, which means from the bottom to the top of that ladder, it's going to be 15. Find the distance from the wall to the bottom of the ladder if the length of the ladder is 1 foot more than twice the distance from the wall. So we go ahead, we know that x is the distance from the base of the ladder touching the wall. Our hypotenuse would be 2x plus 1. In this case, using a squared plus b squared is equal to c squared, this will give us the best opportunity to find our answer. We go ahead, a squared would be x squared, 15 squared would be 225, and c squared would be 2x plus 1 being squared. We would end up with 4x squared plus 4x plus 1. We go ahead and move over all of our terms onto one side and get it set equal to 0. We go ahead, use our calculator, menu, 3, algebra, 3 polytools, 1 finding roots. Yes, it's to the second power. We hit OK. Put in our coefficients, 3, 4, and negative 224. Hit OK. Enter, and we have two numbers that come up, negative 28 over 3 and 8. Keep in mind, whenever we are measuring the distance from the wall, keep in mind this has to be a positive number, which means 8 would be our final solution. If you have any questions in reference to any of these slides, feel free to reach out at any point.